The United States of Chemistry, an exploration of the physical states of matter in chemistry. This presentation will include an overview, procedure, results, and a discussion of the experiment. The purpose of this experiment was to observe changes in states of matter, to explore what causes changes in states of matter, to explain the different states of matter and the changes they go through, and to explore these goals with the aid of common kitchen ingredients. States are very different than the United States of America. However, physical states are used extensively, especially to denote the states of elements and compounds in a chemical equation. Three physical states are solids, liquids, and gases. Solid states have a set volume and a set shape because the atoms are arranged in a very rigid pattern. Liquids have an undefined shape and a defined volume because atom arrangement is a little bit less rigid than solids. And gases have an undefined shape and an undefined volume because atom arrangement is loose and scattered. I predict that the foamy fountain will be in a gaseous state, the gas, slime, and oobleck will both be in liquid states. For the foamy fountain, I mixed hydrogen peroxide and food coloring in a plastic bottle. Then I added dish soap to the bottle and mixed. I added yeast mixture to the bottle and I watched the result. I added the yeast mixture to the soap and hydrogen peroxide and it started foaming up. And as you can tell, if you look really closely, it is still foaming and it has been about a minute since I added that. So that is the reaction of 1 packet of yeast and water mixed with hydrogen peroxide and soap. And it just keeps on going and going into a foamy fountain. Now I'm going to add a solution of half a packet of yeast and water into the hydrogen peroxide and dish soap solution. So it looks like it's filling a bit slower than the full packet of yeast, and we'll see how much it overflows in comparison to the other packet. So now I'm going to add a package of dry yeast to the hydrogen peroxide and dish soap solution, and we'll see what happens. So it's creating a little bit of initial foam and a little bit of an initial gas reaction when added to the hydrogen peroxide and dish soap, but it's not fully rising very quickly or very much at all. It has risen a little bit, but not a lot. This is still the dry yeast and hydrogen peroxide and dish soap mixture, and it's rising more, but it's going at a very slow rate. So obviously the water that's added to the yeast mixture plays a part in the reaction and the formation of the gas. Now the dry packet of yeast has risen to the top and it is overflowing and foaming, but it is overflowing and foaming at a very, very slow rate in comparison to the other two trials with the full packet of yeast and water and then with the half packet of yeast and water. But it keeps flowing and overgoing. For the GAC slime, I dissolved borax with water, and then I mixed glue and water in another container. I added some of the borax solution to the glue mixture, and then it was time to play. Here is the GAC slime mixture that I made by dissolving 5 grams of laundry borax in 75 milliliters of water. And then I mix 1 tablespoon of white glue with 15 milliliters of water. And then I added to the glue and water 10 milliliters of the borax and water solution. And as you can see, it has kind of a liquid but solid shape because it appears to be solid. When I squeeze it and try to make a ball, it will hold its shape for like a little bit, and then it starts to soften and ooze out again, proving that it's not really a solid. So now I'm holding the GAC slime by one end, and as you can see, it's dripping down and it is forming a longer GAC string of sorts. And this looks like it has a liquid shape because it has a definite volume but an indefinite shape. So that's the GAC slime. So the GAC slime holds its shape just a little bit when resting on a platter, but when I touch it and I sort of squeeze it and mash it around, the shape changes of the GAC slime. It doesn't stay in just one shape, it oozes and gets all over the place. For the oobleck, I began with water and then I added small amounts of cornstarch until the oobleck reached a thick liquid state that almost looked like a solid. This is the oobleck that I made by mixing 240 milliliters of water with enough cornstarch to make a thick liquid mixture. And so when I drop my fingers into the bowl, you can see that my finger bounces off and it doesn't get very much oobleck residue on it. But if I dip my hands into the bowl slowly, it oozes in and I can pick it up and kind of squeeze it and it'll be solid for a little bit, and then it oozes back out into a liquid. So now I'm just going to play around with the oobleck to see what types of properties it has. And so I have a knife and I'm going to try to cut through it slowly, and it goes very slowly through when I move the knife through slowly. But if I try to move it through it quickly, it appears to sort of, cut the mixture. And so when I jab it, the knife bounces off of the oobleck, but I can kind of sink it in slowly, and I'll move very slowly, like moving through a liquid. My hypothesis was correct when it came to the foamy fountain. It indeed produced a gaseous state due to the chemical reaction between yeast, water, hydrogen peroxide, and dish soap. When writing formulas and predicting products, gas is often a state that occurs, and it is important to make sure that we know the properties of a gas. The state of the GAC slime was a bit more difficult to describe. I thought that it was a liquid state because it had a definite volume and an indefinite shape. I was able to mold and poke and prod the GAC slime so that it took on different shapes, proving that it is indeed not a solid due to the less rigid arrangement of atoms. Oobleck also appeared to be a liquid due to its defined volume yet undefined shape and a less rigid formation of atoms. It appeared to be a solid at some points due to the constrictions placed by force and pressure when I was squeezing the oobleck. However, the oobleck followed the description of a liquid most consistently, so that's why oobleck is a liquid. Overall, the foamy fountain showed a gaseous state, while the GAC slime and oobleck showed liquid states. The states of matter are determined by the arrangements of atoms. Gases have a very scattered atom arrangement, while liquids have a little bit more defined arrangement of atoms. Physical states are a necessary part of chemical equations because elements and chemicals can be present in different states, but not two different states at the same time.